All right, let's get into it. At the very edge of pretty much every secure network, you've got this digital guard, this gatekeeper, standing right between your safe, trusted internal world and the untrusted chaos of the internet. That guard is the firewall, and its job, plain and simple, is to control what gets in and what gets out. Today, we're going to break down exactly how these critical defenses actually work.
Okay, so what is a firewall's core mission? You can think of it like a bouncer at a super exclusive club with a really strict guest list. It's the policy enforcer. It checks every single data packet trying to get in or out and makes a decision. Allow it, deny it, or maybe just log the attempt for a security admin to check out later. Now, look at that hacker insight box. This is absolutely key for you to understand as an ethical hacker. A firewall is basically a robot. It just follows the orders it's given. That's the access control list. It doesn't think for itself. So if a rule doesn't specifically say, let this in, the default should always be to block it. We call that deny by default, and it is fundamental to good security.
So before we start building up our digital fortress, we really need to know what kind of bricks and mortar we're working with. So let's start with the two fundamental forms a firewall can take, because this choice, right at the beginning, is the first step in building a truly layered defense.
So firewalls really come in two main flavors. You've got hardware and you've got software. A hardware firewall is a physical box, a dedicated piece of equipment that protects the entire network perimeter. Think of it like the main gate in the giant stone walls of a castle. A software firewall, on the other hand, runs on an individual computer, like your laptop or a server. That's more like the personal guard assigned directly to the king inside the castle. Now, a truly strong defense is going to use both. You want those big perimeter walls to stop the big, obvious attacks, and you want those personal host-based firewalls to protect your most critical assets on the inside.
So we've got our castle walls and our personal guards. Great. But, not all guards are created equal. Over the years, they've gotten a whole lot smarter. They've evolved from just, checking an ID at the gate to being able to understand entire conversations. We're going to trace that evolution of intelligence and see how firewalls learn to inspect traffic at deeper and deeper levels. The earliest, most basic type is the packet filtering firewall. This thing operates down at layers 3 and 4. The key thing to know here is that it's stateless. So imagine that bouncer again, but this one has absolutely no memory. He checks every single ID every single time someone tries to come in, even if they literally just stepped outside for a second. He has no idea who's already in the club. And as that hacker insight points out, this is a huge problem. This stateless nature makes it really vulnerable to something called IP spoofing. That's a trick where an attacker fakes the return address on their packet to make it look like it came from a trusted person already inside the network. And our dumb bouncer, he falls for it and lets them right in.
Now let's look at the massive jump in intelligence. In contrast to that simple bouncer, a stateful firewall is really the gold standard today. This is the smart bouncer. Once you're on the club, he remembers your face. He keeps a list, a state table of every single active, legitimate connection. So if some imposter tries to sneak in pretending to be part of your ongoing conversation, this bouncer knows they don't belong and immediately kicks them out. It is so much harder to fool because it understands the context of the conversation, not just the address on the envelope.
Okay, so we've covered the different types of firewalls, the technology behind them. Now let's switch gears and talk architecture. We're moving from the what to the where and the how you actually place them in a network, because a firewall's effectiveness depends enormously on its placement and the other tools it works with.
Right, so firewalls don't work alone. They have some really important allies. A proxy server. Think of it like a personal shopper for your network. You tell the proxy of what you want from the internet, it goes out and gets it for you and brings it back. The internet store never actually sees you. It breaks that direct connection. Then you have VPNs, which create a secret encrypted tunnel right through the public internet, making all your traffic completely unreadable to anyone snooping. And finally, network address translation, or NAT, which is amazing. It hides your entire internal network of computers behind one single public IP address.
Now here we're looking at two foundational blueprints for how to set things up. On the left, you see the Bastion host. This is a single point of entry approach. I want you to think of it as one single, heavily fortified gatehouse. Everything and everyone has to pass through this one super hardened machine. Now on the right, you see the multi-homed firewall. This acts more like a central command post. It uses multiple network cards, multiple interfaces, to physically separate different network zones, one for the scary internet, one for the safe internal network. And it forces all traffic to pass through its logic to get from one zone to the other.
And this right here, this illustrates one of the most important architectural concepts you will ever learn, the DMZ, or Demilitarized Zone. Think of this as the castle's outer courtyard.
It's a buffer zone that sits between the untrusted internet and your super trusted internal network. This is where you put all the stuff the public needs to see, like your web server or your email server. It's the place where you can meet with visitors and merchants without ever letting them into the main castle keep where the real treasures, your private data, your workstations, are stored.
Okay, so we've built our castle. We've set up our defenses. Now we have to put on a totally different hat. To truly defend a network, you have to understand how an attacker sees it. You have to learn how they scout, how they probe, how they look for weaknesses in your defenses.
Two of the most basic methods an attacker will use are port scanning and banner grabbing. Port scanning is pretty straightforward. It's like walking around the castle walls and methodically checking every single door and window to see which ones are unlocked. Banner grabbing is even easier. A lot of times, if a service is running, it'll just announce itself. It'll say, hey, I'm an FTP server, version 2.3.4. Now the key point here, and the hacker insight nails it, is that not turning those banners off is like leaving the blueprints for your entire security system sitting on the front porch for any attacker to just pick up and read.
So port scanning is like checking for open doors. But what if you could figure out the guard's entire rulebook without them ever even knowing you were there? Well, that's the whole idea behind a much more advanced technique called firewalking. It's a really clever way to map out not just the firewall's rules, but also the layout of the network that's hiding behind it. Okay, let's walk through this, because it's pretty cool. It's basically like using sonar. An attacker sends out a ping, just a packet, but it has a special setting called the time to live, or TTL. The TTL is like a countdown timer on the packet that ticks down by 1 every time it passes through a router, or a hop. The attacker carefully crafts this packet so the TTL will hit exactly 0 one hop past the firewall. Now, if the firewall's rules allow that packet through, like in scenario A, it passes to the next router, the TTL expires, and that router sends back a helpful ICMP time exceeded message. The attacker gets the echo. But if the firewall blocks the packet, like in scenario B, it just gets dropped. Nothing happens. Silence. By doing this over and over for different ports, the attacker can map out exactly what the firewall allows and denies.
And all this talk of getting around firewalls brings us to a really critical point. While firewalls are absolutely essential, please remember they are not invincible. They have inherent weaknesses, real blind spots that every single security pro has to understand. They are not a complete solution.
So here are the big blind spots. First, as we've seen, they can be fooled by tricks like IP spoofing. And they are completely blind to encrypted traffic. That's what payload invisibility means. It's like a guard who can check the address on a locked metal box, but has no way of knowing if there's a bomb inside. But even more critically, a firewall is a perimeter defense. It's completely useless against an internal threat. You know, a disgruntled employee who already has legitimate access. And it can't protect you at all from attacks that target people instead of technology, like phishing and social engineering.
And this might be the most important limitation of all. Firewalls are only as effective as their administrators. Just let that sink in for a second. You can have the most advanced, most expensive firewall on the planet, but one simple human error, a misconfigured rule, a default password that never got changed, can make it all completely worthless. The technology is only one part of the puzzle.
Okay, so let's pull all of this together. Let's summarize the key principles, the big strategic takeaways you absolutely need to remember for building a truly resilient security posture.
Here are your 4 big takeaways. Number 1, technology. You've got to choose the right tool for the job. You have to balance the speed you get from simple packet filters with the much better security of stateful inspection. 2, architecture. Design for resilience. Use those smart concepts like the DMZ to isolate your public services and protect your internal treasures. 3, recognitions. You have to think like an attacker. You need to regularly scan your own perimeter, probe your own defenses, and find the cracks before they do. And finally, number 4, layered defense. Always acknowledge the limitations. A firewall is just one layer. It has to be supported by other tools, like intrusion detection systems, antivirus software, and maybe most importantly of all, strong, well-enforced security policies for your people.